start this talk with a quick survey. Who doesn't like lawyers? Please raise your hand. Okay, it seems to me you like lawyers, and that's pretty good. Why am I asking? I was working as a lawyer before, but then I got bored, learned to code, and became a developer. I'm also a blogger, so if you're interested, you can check my blog, codinglawyer.net, or you can tweet at me at coding_lawyer. I work at Blueberry, where we develop mobile and web applications using cutting-edge technologies. And we are also organizing a conference about functional programming called Lambda. It will take place this September in Prague, so if you're interested, you can check the websites lambda.io. Second question. Who programs in React? Please raise your hand. So many of you, great. And I bet that most of you want to write reusable and maintainable components. Am I right? Because otherwise, you might end up with a lot of duplications all over your code, and such code would be difficult to maintain and to scale. Fortunately, there are several ways how you can address this issue. You can use render props, or you can use higher order components. And today, I will talk about higher order components, because we've used this pattern in a couple of our projects, and it really helps us keep our code base maintainable. And I believe it can help you as well. So, let's check the agenda for today. We'll be talking about React, then we will move to higher order components, their reusability, their composition, then we will talk about Recompose library, and then we will conclude. And because we are all programmers here, and we love to code, let's start by checking some code. Here, we have an array of Star Wars characters. It's an array, and each element consists of a name and side, depending to which side the character belongs to. We will take this array and pass it to the filtered list component as a list prop. Now, filtered list component is a little bit complicated, and you don't need to understand what's going on right away, because we will be talking about parts of this code throughout the talk. So let's take a look. We are maintaining state called side. It's dark or light. Then we have a state handler, and when it's called, it will just toggle the sides. So it will change the side dark to light, and vice versa. Then we have our render method. Here we filter the list of Star Wars characters according to the side, so we will get characters belonging to the dark side in this case. Then we have a condition. If our array has more than 2 characters, we will display the array, display the button which toggles the state. If our array has less than 2 elements, we will display the warning message instead. Now, this code takes care of a lot of stuff. There's just too much functionality in this component, right? And because of it, it's hardly reusable. We cannot just take a piece of this code and use it elsewhere. We can think about this component like this. It's a filtered list component combining logic and presentation, and is hard to reuse. At the end of this talk, we'll be able to rewrite this hard-to-reuse piece of code to reusable and maintainable React component composition. But first, let's talk about more React about general way. React components are composed of logic and presentation. However, you don't want to write all your components like this, because you would end up with components having only a single purpose, hard-to-reuse components. However, if you separate these two concerns, logic and presentation, you will be able to create reusable components. And if you stick to this pattern, you should be defining your components as smart and presentational. Presentational component takes care only of the UI, is just a render method. On the other hand, smart component takes care of all your logic, all the API calls, data manipulations, event handlers. And if you need some more advanced logic, you will define your smart component as a class. So let's take a look at the presentational component. Again, we have a list of Star Wars characters, and we pass it to the display list component as a list prop. And display list just displays the list of Star Wars characters. Now, this component is reusable easily because it takes care only of a single concern, only of the UI. If we wanted to display Star Wars characters elsewhere in our application, we can use this component. Now, let's say we would like to add some logic to this component. Let's say we would like to be able to filter the list of Star Wars characters before it gets rendered. So how could we do that? Well, the most straightforward solution is to this is the illustration of our we have display list reusable component. So we just add the logic. Now we move the logic inside the filtered list component. So let's see how this works. We pass props to the filtered list component, list prop and new side prop. Now it's dark. So we go to the component. Here we filter the list of Star Wars characters using the side, and then we displace the filtered list of Star Wars characters. But we have a problem because this component is hard to reuse. Because if we wanted to display Star Wars characters elsewhere in our application without any filtering logic, we can't use this component because we are stuck with the filtering logic there. And if we wanted to reuse the filtering logic, we can't do that because it's buried inside the component. So if we imagine it, we can think about it like this. It's a component combining logic and presentation, which is hard to reuse. So the question is there any other solution how we could achieve the same result but to keep our presentational component reusable? Fortunately, there's one more elegant and declarative solution how we could achieve this. Let's take a look. What we did here is that we move our logic to with filter props higher order function. Let's first take a look how this works. We have our filtered list component, and as you can see, we are passing the display list, our presentational component, to with filter props. Now, when we do that, we go to with filter props, and now we pass display list as a base component, so we get display list inside a closure, so we can access it later. And we get back a new component waiting for the list and side prop. And we store this component as filtered list. So filtered list is a component waiting for the props. So we pass it props. When we do that, the props goes to the filtered list component. That is the component returned from the with filter props. Here we use our filtering logic and filter the characters, so we get characters belonging to dark side, and then we just displace the list of Star Wars characters. Now, I'd like to talk more about the with filter props higher order function. In React's vocabulary, we call it higher order component. And just as the higher order function returns a new function, higher order component returns a new component. Higher order component is a function that takes component and returns a new component that renders the past one. And this resulting component is enhanced by some additional logic. This is the enhanced component. And if we take a look at our example, what we did here is that we pass display list to with filter props, and we get back a new component that renders the display list component and is enhanced by the filtering logic. If you take a look at our example, what we did here is that we abstract the logic to the higher order component, and our base component became reusable again. If we visualize it, we are right here. We have a reusable presentation component and a higher order component that inject a piece of logic to it. You can store whatever logic you want inside your higher order component. You can maintain state, you can transform props, you can deal with the lifecycle methods, whatever you want. And this is the power of the higher order components. You can think of them as wrappers for your presentational components that lets you to inject a piece of logic to your component. And if you stick to this pattern, you don't need to define your component as your base component and as classes anymore, because they take care only of the UI. Okay, since it's almost dinner time, let's slow down a little bit and talk about food. At the beginning, we saw this hard-to-reuse component, combine logic and presentation. Now, I want you to think of this component as a meatloaf. Now, when preparing meatloaf, you take eggs, meat, onion, garlic, mix them together, and put the raw meatloaf into the oven. When it's cooked, you just cannot take eggs or meat from the meatloaf because everything is irrevocably combined. And the same applies to this component. We just cannot take piece of behavior and reuse it elsewhere. No. Now, I want you to think of presentational components as of pancakes. But simple pancakes are pretty boring, and no one eats them like this anyway. So you would like to add some toppings. Imagine pour them with maple syrup or add some berries. So many choices. And in React, these toppings are represented by higher order components. And just as you can decorate your pancake with topping you like, you can decorate your presentational component using higher order component that contains logic you need. So as a result, you can reuse your presentational component throughout your application and decorate it with a higher order component that contains logic you want. Okay. I hope that this little foot analogy helped you to understand higher order component pattern better. And if not, that I guess at least I made you hungry. So now we know how to create a higher order component. So let's take a look how we could make it reusable. Making components reusable means we want to decouple them from the data. We don't want them to be dependent on a particular prop structure. If we take a look at our previous example, here we move the logic to the higher order component, and our base component became reusable. But we have a problem because our higher order component is not reusable. And why? Because it's dependent on a particular prop structure. We can use it only in the cases where list and side props are available to us. So if we visualize it, we are now here. We have a reusable presentational component and not a reusable higher order component. So question is, how could we make our higher order component reusable? We can pass the logic from the outside. Let's take a look. Here we have a reusable version of our higher order component. There are two main differences. First, we renamed it. It's now called with transform props because it's no longer limited only to the filtering logic. But more importantly, we have a new parameter here called transform func. This is so-called configuration function. And this function takes care of our logic. Before, we were stuck with the logic inside the higher order component. But now we are passing it from the outside. And inside the component, we pass props to our transformation function. So the transformation function takes the props and transforms them in some way. A cool thing about this function is that it takes care of also of the prop structure. So we can pass different configuration function each time depending what kind of logic we want and what kind of props are available to us. So let's take a look how this works in our example. This example is pretty similar to the previous one. Instead, we are using the reusable version of higher order component. Let's take a look. Again, we have filtered list component and with transform props higher order component. Before, we were firstly passing the display list component, but now we are passing our configuration function. And as you can see, configuration function takes list and side prop and returns a list of filtered Star Wars characters. So we take this function and pass it to with transform props. Now we are here, and we have transformation function inside the closure, so we can access it later. And we get back so-called configured higher order components. It's a higher order component that has the configuration function inside the closure. And this configurable higher order component is waiting for the base component. So now we pass our display list as before. Now we have configuration function and display list inside the closure, and we get back a component waiting for the props. And we store this component as filtered list. So filtered list is our display list component enhanced by with transform props logic. It's waiting for the props. So we passed props, And we do that, the props goes to the filtered list component. That is the component returned from with transform props. Here we have our configuration function inside the closure. So we use it to filter props. We will get a list of filtered Star Wars characters. Then we will pass it to the base component. That is our display list. And display list just displays list of Star Wars characters to the screen. Now, the idea behind this approach is that we want to be able to configure our with transform props higher order component for any scenario in which we want to do something with props. Here, we want to filter the props, so we pass the filtering function. Here, we are using the same higher order component with transform props, but we are not filtering anything anymore. We are adding new element to our array. We are adding Han Solo to the array. And this is the reusability of a higher order component. If we take a look again at our example, our higher order component and our presentational component are both reusable and independent of each other. The higher order component doesn't know where its data goes, and the presentational component has no idea where its data is coming from. If you stick to this pattern, writing your components and higher order components reusable, it will help you to avoid unnecessary duplication inside your code. And as a result, your code will become more reusable and maintainable. If we take a look at the visualization, we are now here. We have a reusable presentational component and a reusable higher order component. And this pattern, by passing configuration arguments, is really common for higher order components. If you know Redux, who use Redux? Raise your hand, please. Cool. If you use Redux, you know connect higher order component. And it's the still same idea. Connect takes two configuration functions, map state to props and map dispatch to props. Map state to props returns a piece of state. Map dispatch to props returns some global state handler. And what connect does is it calls the function and pass the result to the component, inject the result as props. So it's still the same idea. Okay, now we know how to create a reusable higher order component. So let's create another one. Here we have a with condition higher order component. The idea is still the same. We are passing two configuration arguments here, condition func and either component. And inside the component, we pass the props to the condition function. That function returns true or false. If it returns true, we display the passed either component. If it returns false, we will display the base component with props. Now, this is pretty common higher order component. You can imagine it if you want to display loader instead of component when you don't have data yet. You would use this higher order component. Okay, let's say we would like to enhance our presentational component by two higher order components at once with condition and with transform props. How could we do that? Well, we can use composition for that. But first, let's take a look at the example of functional composition. Here, we have a number and three, I think, self-explanatory functions, increment, decrement, and multiply. Now, composition means that we pass the result of the first function as an input to the second function, the output of the second function as input to a third function, and so on until all functions are called. So what we do here is that we wrap all three functions inside each other, and we pass the number to the last one. So multiply takes number, return result. That's taken by decrement, we get the new result. Increment will take the result, and we get our final result. So composition is about wrapping functions inside each other. And the same applies to the composition of higher order components. So let's take a look. Here we have two higher order components we've seen before, with transform props and with condition. Then we have two enhanced components, conditioned list and filtered list. Then we have a display list component and warning component. That's the new component that displays the warning message, as you can see. And then we have our render method. So let's see how this works. we get started with conditioned list. So as you can see, we have a with condition higher order component, and we are passing two configuration functions to it. Two configuration arguments. Is a function that takes the list of Star Wars characters, and if it has more than two elements, it would return. If it has less than two elements, it will return true, otherwise false, and our warning component. So we pass these configuration parameters to the with condition. Here, we have these two parameters inside a closure, and we get back a new configured higher order component waiting for the props, waiting for the base component. So we pass it the base component display list. And when we do that, we have our display list inside a closure, and we get back a new component waiting for the props, and we store it as filtered list. As conditioned list. So conditioned list is our display list enhanced by with condition higher order component. So let's move on. Now we have a filtered list component. And as you can see, we are passing the configuration function to the with transform props. It's a function that takes care of the filtering logic. We pass it to with transform props. Now we have our configuration function inside the closure. And we get back configured higher order component waiting for the base component. And now we pass a conditioned list as our base component. So we have our configuration function and our conditioned list inside a closure. And we need to remember that conditioned list is already enhanced component, is a display list enhanced by with condition. So we are enhancing already enhanced component. So when we do that, we get back a new component waiting for the props, and we store it as filtered list. So filtered list is our higher order component composition. It's a display list enhanced by with transform props and with condition. So we can render it now. Let's pass props to it. Our list and side prop. These props go to the with filtered list component. That is the component returned from with transform props. Here, we have our configuration function inside a closure, our filtering function. So we filter the list of Star Wars characters and pass the filtered list to the base component. And base component is conditioned list. And conditioned list is a component returned from the with condition. So we go to with condition. Here we use our configuration function, and we pass props to it. So as again, the function means if we have less than two elements in the array, we will get true. So if we will get true, you will display the warning component. Otherwise, we will display the display list component. So warning or display list. So again, what we did here is that we enhance our presentational component display list by two higher order components with transform props and with condition. The more general idea is that we don't store the logic inside single component. We abstract it to the higher order component and separate it. So our complicated logic is separated, and then we compose the logic using composition and enhance our presentational component by this logic, by this higher order component composition. And we've also seen that props is the only language the higher order components can talk to each other inside composition. Higher order components takes props, perform some action, and pass the resulting enhanced props down the component structure. However, we have a minor problem, because this syntax is pretty verbose. I mean, we don't need to store the first part of the composition inside conditioned list variable. We can just wrap the higher order components inside each other like this. But the readability of this is also not that good. Imagine if you had like 10 higher order components. This would be really difficult to read. So the question is, how could we make this more readable? We can use functional programming compose helper for that. So here, we pass our two higher order components to the compose helper. When we do that, we get back a configured higher order component waiting for the base component. And we store this functionality as an enhance. I mean, like enhancing something. And in our example, we pass the display list, our presentational component, to enhance and store it as filtered list. Like we are enhancing the display list. And this is really cool because because when we pass the display list to enhance, our compose, what it will do all the wrappings for us. We don't need to wrap our composition manually because compose will take care of that. And if we take a look at our resulting syntax, it's much more readable because compose is doing all the dirty work for us, all the wrappings. And that's really useful. And if we visualize it, we are here at this stage. We have two reusable higher order components, and we are injecting their logic to our reusable presentational component. Now, I'd like to come back to our pancake analogy. Before, we were decorating our pancakes only with a single topping. But pancakes taste much better if you add multiple toppings. Imagine cream and caramel or melted chocolate with banana. You know what I'm talking about, right? And just as you can decorate your pancakes with multiple toppings you like, you can decorate your presentational component with multiple higher order components that contains logic you want for your particular use case. So if you find yourself in a situation when you need a complex logic for your component, you don't store it in the single component or in the single higher order component. No. You separate the complex logic to two higher order components and enhance your presentational component by them. Okay. So far, we've seen examples of custom higher order components, but this pattern is so powerful that it has been used in many React-based libraries, such as React Redux, Recompose, or React Router. And today, I'd like to talk about about Recompose library, which provides us with many predefined higher order components. So let's try to rewrite our example using Recompose. Let's take a look. Our two custom higher order components, with condition and with transform props, are already predefined in Recompose as with props and branch. And Recompose also provides us with predefined version of compose. And as you can see, the resulting example is basically the same as our custom one. The only difference is that the branch takes as a second argument higher order component. So we just redefine warning component to with warning higher order component. So let's try to use more predefined higher order components from Recompose. Let's say you would like to be able to have a button inside our component, and when we click the button, we will toggle the sides. And to do this, we need to be able to maintain internal state. And we can use a helper from Recompose for that. Let's take a look. Now we added a new higher order component to our composition. We added withState higher order component. And withState takes three configuration arguments: name of the state, name of the state handler, and the default state value. We called our state, our state handler setState, and our default state is dark. So this is the value of the site. It will be dark or light. Previously, we were passing this information as a props. Now we are storing it as internal state. So we have our with props higher order component. Then we have a branch higher order component. We store this as enhance. We get back a configured higher order component waiting for the base component. So we pass it the display list, store it as filtered list, and we pass the list to the filtered list. So we are no longer passing the site prop because we are storing site inside a state. So we pass the list. The list goes down to its state. Here we enhance our props by state and set state. So our props are list, state, and set state. We go down to with props. Here we use our state and list and we filter the list of Star Wars characters, and we get back a new prop called filter that is then added to the props. Then we go to branch. Here we will check what to render. And finally, we arrive to our display list component. Here we display the list of Star Wars characters, and we have a new button here, and we pass it on-click handler, set state. So when you click the button, the sides will be toggled, and we will see the characters belonging to the opposite side. Now, as you can see, we are passing the logic to set state that just check what is the current state, current side, and we just toggle it. This is pretty cool because we don't need to transform functional component to class 1 when we need to maintain state. We just abstracted the state to higher order component. But we still have a minor problem, because if we take a look at this, our handler gets recreated each time the component re-renders. And we don't want to we don't want to have this, because this might hinder the performance of our application. So how could we solve this issue? We can use another higher order component for that. Let's take a look. Here we added a new higher order component with handlers to our composition. And with handlers takes a single configuration argument called, it's an object of functions. In our case, it's an object with only single function called toggle state. So now we store it as enhance. We pass a display list, then we render it, our filtered list. We pass props to it, so list goes to with state. We enhance it, we go to with props, branch, and finally our props arrive to with handlers. And when the props arrived, our handler toggle state will keep state and set state inside a closure and return this handler. And as you can see, previously, this handler was inside the display list component. Now again, we abstracted this logic to the higher order component. And what with handlers does is that it enhances props by this toggle state handler. So we go to our display list component, and we attach our handler to the button. So now this handler is not recreated each time the component re-renders. And this is thanks to with handler's higher order component, because it caches the handler. I know what you're thinking now, probably, because you are thinking that we don't need this performance optimization for this little super tiny example. And you were right. With handler's higher order component really shines when you have, for example, 8 handlers. In that case, each handler is cached, and this might really improve your performance. Another great thing about this higher order component is that if you want to know what kind of handlers your component uses, you just check the with handlers higher order component, and they are all there. You don't need to search your component for the handlers manually. So we've seen some pretty nice examples of recompose helpers. And by providing us with so many predefined higher order components, Recompose makes usage of higher order components in general and their composition much more easier for us, because we don't need to define these higher order components ourselves. In the real world application, you will use these predefined higher order components quite often, because they cover most typical use cases. And if you find yourself in a situation when you need some more specific logic, you define higher order component yourself. Now, if we take a look what we achieved, we are enhancing our display list presentational reusable component by 4 higher order components. We are injecting logic from these components to our presentational component, and all of the components are reusable. Okay, to conclude, we were able to transform this hard-to-reuse piece of code to this reusable, maintainable, and readable higher-order component composition. Now, we use higher order components quite often because our goal is to write reusable components as much as possible. And higher order component helps us with it because its idea is to abstract logic to the higher order components and let the base component take care only of the UI. As a result, we don't need to use classes for our base components. We use classes only for the higher order components when we need to maintain internal state or deal with lifecycle methods. So as a result, we end up with a bunch of presentational components that we can reuse throughout the application and decorate them with one or multiple higher order components depending on what kind of logic we need for our use case. For example, we use higher order components for data fetching. We have a higher order component, and we pass some configuration parameter to it, telling it what kind of data from the server we want. And when our component renders, the higher order component will take care of that this data is available to us. Or we've seen examples that we used higher order components to keep local state using with state from Recompose, or to maintain global state using connect from React Redux. And we also abstracted local storage or cookies logic to the higher order component as well. See, you can really store whatever logic you want inside your higher order component. Another great thing about this pattern is that if you take a look at your higher order component composition and you want to know what kind of logic your component uses, you just check the compose method. All the logic's right here. And if you want to add some more logic, you just add a new higher order component to your composition. The same applies to with handlers higher order component. You don't need to look for your handlers all over your component. You just store them inside with handlers, and if you want to know what kind of handlers your component uses, you just check the with handlers. Another great thing about the higher order component pattern is that it's not related to React it's not dependent on React in any way. So you can reuse them only in the applications that haven't been built in React. Well, that's all from me. If you have any question, observation, or criticism, you can tweet at me, coding_lawyer, or you can reach me via my blog, codinglawyer.net. And of course, if you have any question, you can ask me in the speaker's corner. Thank you very much.
Cool. Thanks a lot.